Good evening, friends. Good evening, friends. Welcome to Unacademy classes YouTube session. My name is Dr. Manjunath. Good evening, friends. I shall be discussing with you today good evening, friends, the concepts of differentiation. Unacademy classes YouTube. Today we shall take up the concepts of differentiation here. As you all know that this is one big branch under calculus. The term of differentiation itself discusses various aspects of the continuity, limits, and differential coefficient contents. If I say y is equal to f of x to be a continuous function of x, then f dash of x, which is called dy by dx, is equal to limit delta x tends to 0, f of x plus delta x minus f of x by delta x. If this exists, it is called the derivative or differential coefficient. Friends, these two are the fundamental terms. Either the word of derivative can be used or the word of differential coefficient can be used for this. So, my earnest request is, please make sure that you know these concepts very well before you get on to applying these into your sums. F dash of a exists, then f of x is continuous at x equal to a, but its converse is never true. Mod x is continuous at x equal to 0, but not differentiable at x equal to 0. F dash of a plus 0, which is called right hand derivative, RHD means right hand derivative. You can see the word here, right hand derivative. LHD means left hand derivative. What you find on the LHS, like you use the word LHS and RHS, we similarly use here right hand derivatives and left hand derivatives. That's the thing. So f of x minus f of a by x minus a, when limit x tends to a, it can be said as limit h tends to 0, f of a plus h minus f of a by h. And in case of left hand derivative, it is said as f of x minus f of a by x minus a, where limit x tends to a minus, that is limit x h tends to 0, which is f of a plus h minus f of a by h. Friends, let's see this with an example here. Consider f of x is equal to x minus 2 at x equal to 2. F dash of 2 plus 0 is equal to limit h tends to 0, 2 plus h minus f of 2 by h. As h tends to 0, this whole sum changes to h minus 0 by h, which is nothing but h by h, which is 1. Very simple concept to understand the concept of RHD and LHD. And in case of LHD, f dash of 2 minus 0 f dash of 2 minus 0, limit h tends to 0 h by h. Here, since it is LHD, please look at the formula. The limit value will be in terms of minus. So the answer remains minus 1. See, LHD you have got it as minus 1. RHD you have got it as plus 1. Both are not equal to each other. What is said? LHD is not equal to RHD. That means for this function, f dash of 2 does not exist. You can't have a value of 2 for this differentiated equation. Let's see one more example, friends. Consider x at x equal to 2. F dash of 2 plus 0, limit h tends to 0, 2 plus h minus 2 by h. Limit h tends to 0, 2 minus 2 by h is 0. And at the same time, f dash of 2 minus 0, this is for LHD, limit h tends to 0 minus, that is 2 plus h minus 2 by h. Limit h tends to 0, 1 minus 2 by h, which is infinity. And here also, RHD is 0, LHD is infinity. So they are not equal. So f dash of 2 doesn't exist here. In other words, it can be said like this: f of x is not continuous at x equal to 2. This we have got the idea from the previous chapter, continuity and limits. We have realized about it, isn't it? That's the same thing. Now, I'll give you one more equation. Now, this problem is by using the graph you need to discuss. Look at the graph for a while. The function is represented by the following graph. On the y-axis, or it cuts the y-axis at 1 and it touches the x-axis at 1. So what is the value that need to be taken up here, or how do we define this? You can see it on x-axis at 1, x equal to 1, there is a sharp edge. Therefore, it's not differentiable at x equal to 1. It's not differentiable at x equal to 1. One more aspect, what is observed? Continuity is very clear from this particular figure because it's not ending here. Continuity is obvious, that is seen in the figure. So how do we infer this? It is continuous, but it cannot be differentiated at x equal to 1. So the right answer is first option, not third. Third is wrong. It is first option. It can also be said like this. Take the graph y equals mod x minus 1, correct? Which is not differentiable at x equal to 1. You can't differentiate this at x equal to 1. X equal to 1, what happens? 1 minus 1, 0. But that is not correct. So it is not differentiable at x equal to 1. But it is a continuous function. Hope the concepts are clear to you. Next. I think the screen is clearly visible now, isn't it? Let me take another sum. F of x is equal to x minus 1 by 2x square minus 7x plus 5 for x not equal to 1. And f of 1 is equal to minus 1 by 3. You are supposed to find here f dash of 1. Differentiate it and find f of 1, f dash of 1 here. Okay. F of x is continuous at x equal to 1. That need to be checked. How do we do this? F dash of 1 is limit x tends to 1, f of x minus f of 1 by x minus 1. When x is very close to 1, f of x is equal to x minus 1 by x minus 1 into 2x minus 5. Just see, the denominator is factorized. 2x square minus 7x plus 5. 2x square minus 5x minus 2x plus 5. If you take x common, 2x minus 5 minus 1 common, 2x minus 5. So 2x minus 5 into x minus 1. Now these are the two roots that you have got here. Am I right? Cancel x minus 1, both the place numerator and denominator. What's remaining? 1 by 2x minus 5. Now how do we take this? See, it is 3 plus LCM you should take. When you take LCM, denominator 2x minus 5 into 3. So it is 3 plus 2x minus 5. So 2x minus 5 plus 3 is minus 2, correct? 2x minus 2 you will get. And take out minus 2 outside. Take out minus 2. Correct. Yeah, take it out. It will be, take 2 out. It's not minus 2, 2 out. Take 2 out, it will be x minus 1 by x minus 1. Cancels. In the denominator, it so happened No, this minus exists. Sorry, it minus exists. See what happened in the numerator, it was 2x minus 2 by 2x minus 5 into 3 into x minus 1, correct? X minus 1 gets cancelled. What is remaining here? 2x minus 2 divided by 3 into x minus 1 into 2x minus 5, correct? Now take 2 common, x minus 1 divided by 3 into the x minus 1 goes off, let me say. X minus 1 goes off. So what is remaining here? What is remaining here? 2 divided by 3 into 2x minus 5, correct? Now you have to see the LHD and RHD comparison here by putting up x is equal to 1 in this. So if you put x is equal to 1, so 2 ones are 2, 2 minus 3 is minus 5 is minus 5 plus 2 is minus 3. Minus 3 into 3 is, that is minus here. That is minus here. 9. 3 into 3 is 9. Minus 3 it is. 3 3s are 9. So 2 by minus 9 is going to be the answer. So this is plus only. Clear? Please understand this. It's a mere mathematical calculation. We just did the differentiation at the last step. Let me take up one more example so that it is a little more clear to you. Then next question, the function f of x equals x minus 2 plus x is what it is. Differentiable at x equal to 2 and x equal to 0. Differentiable at x equal to 2 and but not at x equal to 0. Continuous at x equal to 2 but not at x equal to 0. Continuous at both x equal to 2 and x equal to 0. Let's see the solution. The function x is differentiable function and hence it's a continuous function. The x is here differentiable function and it is continuous too. The x minus 2 function is continuous function but it is not differentiable at x is equal to 2. Therefore, what is the right answer? F of x is continuous for all x. F of x is continuous for all x and you need to see x equal to 2 and x equal to 0 at both these places. X must be continuous value. First of all, x is continuous in this function. When you take a 2, it is continuous but it is not differentiable, and at 0 always it is continuous and differentiable too. So f of x is continuous for all the values that is given for the value of x. So the right answer here is it is continuous at both x equal to 2 and x equal to 0. Hope these concepts are clear to you. The function f of x equals x square for x less than 1 is, and 2 minus x for x greater than or equal to 1. It's expressed using the diagram here. Hope the concepts are clear to you. X square and 2 minus x. So f dash of x is, when you differentiate x square, it will be 2x, and there it is going to be 2 minus x is, when you differentiate, it is going to be, differentiation of minus x is minus 1. Constant will be 0. So f of x is continuous for all values of x. Note that f of 1 plus 0 is f of 1. So f of 1 minus 0 is equal to 1. But f dash of 1 plus 0 equals minus 1, and f dash of 1 minus 0 equals 2 into 1, which is 2. So it is not equal to f dash of 1 plus 0. So f dash of 1 plus 0 is not equal to f dash of 1 minus 0. It's very well said here. So f of x is not differentiable at x equal to 1. Same concept, I am just repeating it with one more example. Fourth one, let me see how you get this. Which of the following is not true always? If a function f of x is continuous at x equal to a, then limit x tends to a, f of x exists. If f of x and g of x are differentiable at x equal to a, then f of x plus g of x is also differentiable at x equal to a. If f of x is continuous at x equal to a, then it is differentiable at x equal to a. If f of x is continuous at x equal to a, then it is not differentiable at x equal to a. Tell me, what is the right one here? You need to be very careful. The question is, which of the following is not true always? It's not what is true, it is not true. What is false? That need to be identified here. Yeah, the answer is third one. F of x is continuous at x equal to a, then it is differentiable. We have already seen this. It is not possible always. At few specific instances this can be accepted, but it cannot be said as a generalized statement. That's why third one is not a true statement. Hope the concepts are clear. The function f r tends to r defined by f of x is equal to 1 for x greater than or equal to 1, equal to minus 1 for x less than or equal to minus 1, equal to x for x lies between minus 1 and plus 1. Differentiable at every point x belongs to R, continuous every way where R, but not differentiable at x equal to R, x belongs to R, and continuous everywhere on x differentiable at all x belongs to R except at x equal to 1 and x equal to minus 1. You can see the graph that is clearly shown here. Through this, we can understand how well it can be described. This concept is clear. Friends, now slightly I shall move towards the formulas of this. Little jump I took so that you get more clarity and we just follow the things in a very systematic manner. Rules of differentiation. If y is equal to k into u, dy by dx is k into du by dx. If y equals u plus or minus v, dy by dx is equal to du by dx plus or minus dv by dx. Next, I have a problem here. Look at this problem. If the function f of x defined by f of x is equal to x power 100 by 100 plus x power 99 by 99, so on and so forth, up to x square by 2 plus x plus 1, then f dash of 0 is what? You need to be very clear about this. We use a formula here, x power n differentiation d by dx of x power n is n into x power n minus 1. N into x power n minus 1. So if dash of x is equal to, it is 100 into x power 99, 99 into x power 98, so on and so forth, and last value x square can be said as 2x and x is 1, 1 will be 0. Friends, till the last value, rest all has got x in it, and when I put f dash of x as 0, all these values still here, all these become 0. What is going to remain? Only a value called 1. So 0 plus 1 is equal to 1. Next, y is equal to u into v. It's a product rule. dy by dx is equal to v into du by dx plus u into dv by dx. This concept is called as product rule. This is for two values. And similarly, when I take for 3, it is u dash into vw, v dash into uw, and uv into w dash. It's in a cyclic way. You can see u dash, v dash and w dash, and the other two terms can be put along with that. That's how the shortcut can be remembered. This is about product rule. Next, friends, we have what is called quotient rule. When you take y is equal to u by v, dy by dx is equal to v into du by dx minus u into dv by dx by v square. two values are unknown here, and it is said like this. In the simplest form, it can be said v into u dash minus u into v dash by v square. Third is about chain rule. Function. A function within a function is taken. It's all called composite functions or complex functions. F dash of u into du by dx. So dy by du into du by dx, it is chain rule. You can take example. Log of sin x. Wait. If I say this as a first function and this is a function within that, first differentiation of log, that will be 1 by sin x, and then this is log's differentiation. Now sin differentiation is cos x, so it is cot x. This is called chain rule. Okay, let me proceed. Look at all these formulas that are there. If a constant is differentiated to 0, x power n x power minus 1, n minus 1, root x is 1 by 2 root x is minus 1 by x square, and 1 by x power n is minus n by x power n plus 1. Same way you have a chain rule application here. U power n is n into u power n minus 1 into du by dx. Root u, 1 by 2 root u into du by dx. Minus 1 by u is minus 1 by u square into du by dx. 1 by u power n is equal to minus n by u power n plus 1 into du by dx. Sin x differentiation cos x differentiation minus sin x, tan x differentiation secant square x, cot x differentiation minus cosecant square x, secant x differentiation secant x tan x, cosecant x differentiation minus cosecant x cot x. Similarly, chain rule is applied here. Friends, altogether you have here 22 formulas. 22 formulas. To practice it perfectly. Once you know the concepts very well, I will tell you, you know differentiation perfectly. I have few examples to make it more better to you or to make it more thorough. d by dx of 2 power minus x. This is like a power x formula. What is a power x formula? A power x log a. d by dx of a power x is a power x log a. Okay, now 2 power minus x it is. So 2 power minus x into log 2. But see friends, this is not the end of it. If you write only this much, you will lose out marks. You will not be having any marks for this. Instead, if you continue, because there is 1 minus x in this. It's not a power x into log a. See, x further differentiation is 1 here. So that was the reason we got the answer like that. See here. A power u into log a, and this u differentiation is du by dx. Same way x differentiation is 1, so that's why it is 1 here. Whereas here it is minus 1. So this minus x differentiation need to be taken. So now the answer becomes minus 2 power, because minus x differentiation is minus 1. And this minus comes up here. Otherwise your answer is in positive form. It's a very important thing to be remembered. Hope you all have the clarity about this. One more concept, friends. Root cortex. Differentiation of root cortex. Now what is root cortex? This is nothing but root x differentiation. 1 by 2 root x. But you have to be careful, it's a chain rule. Root contains the formula for the root first, then for the cot. So root is 1 by 2 root. Correct? 1 by 2 root cortex. For the cortex differentiation of cortex is minus cosec square x. So minus cosec square x by 2 into root of cortex is the answer. Hope these concepts are clear to you. Minus cosec square x by 2 into root of cortex. Tan inverse 3x dy by dx equals 1 by 1 plus, be careful, tan inverse x differentiation is 1 by 1 plus x square. Tan inverse x, tan inverse 3x it is. It is 1 by 1 plus 3x the whole square. That is the answer there. And for the 3x differentiation chain rule, so you have 3 by 1 plus 9x square. Clear? Next, y is equal to tan inverse of e power x. Tan inverse of e power x. Tan inverse differentiation is 1 by 1 plus x square. 1 by 1 plus x square. Now further, the x differentiation of x need to be taken up. And what is the differentiation of x here? What is x here? E power x. So it becomes 1 by 1 plus e power x the whole square. This is tan inverse x differentiation. And then further, with the help of chain rule, the e power x is differentiated. E power x differentiation is e power x. So what do you get as the answer? E power x by 1 plus, see this is a power m whole power n, that is a power mn, e power 2x. Next, f of x is equal to cot inverse of x square. F of x is equal to cot inverse of x square. So x square differentiation is to be done. First, cot inverse formula. It is minus 1 by 1 plus x square. Minus 1 by 1 plus x square. What is x here? It is x square whose whole square. It becomes minus 1 by 1 plus x power 4. And x square differentiation, which will be 2x. So what is the final answer? Minus 2x by 1 plus x power 4. Minus 2x by 1 plus x power 4 is the final answer. Next, y equals cos square root x. Y equals cos square root x. Three concepts are here. One is about cos, the other one is about square. First is cos, square, and third one is this. So three concepts. So x square differentiation, when you do, it becomes 2x. So cos square differentiation is 2 cos x. Correct? X square differentiation is 2x. So 2 cos, what is x here? Root x. 2 cos root x. So this was number 1. Number 2, cos differentiation. Differentiation of cos, which will be minus sine root x. Minus sine root x. This is number 2. And third is differentiation of root x. Differentiation of root x. So x square 1, cos differentiation number 2, and number 3 root x differentiation. All three, if you take minus, why did you get minus here? Because cos differentiation of cos is minus sine root x. Thus that one we have got it here. Minus sine root. Now be careful friends. Minus sine root x into cos root x into 2. This is like a formula. Sine 2 theta. This is like a formula. Sine 2 theta. Sine 2 theta is what? 2 sine theta into cos theta. 2 sine theta into cos theta. Which is sine 2 theta. Which is sine 2 theta. So we got here minus sine 2 root x minus sine 2 root x by 2 root x. So this is the final formula of the sum. Hope these concepts are clear. I'll erase some of these so that the concept is seen. Otherwise, it's only the problem that will be seen with all my writings. See, here it is just 2 cos theta into sin theta, which is sin 2 theta. This need to be remembered. And this minus sign exists here. Rest. Hope it is clear to you. Next one. Cos of log of sin x. 3 functions are there. You need to be careful. 1, 2, and 3. We have 3 major functions that need to be taken for the clarity. So if I differentiate cos, differentiation of cos will give me minus sine. Rest 2, you don't have to worry, it is the same. Cos, number 1, differentiation. Number 1 is what? Cos. Cos of that composite function. Minus sine. We got it. Next. This is number 1. First differentiation. Correct? Number 2. Number 2 is what? Differentiation of log of sin x. Log of sin x is, here it is. Log of sin x is 1 by sin x. This first part remains the same. Second one, log of sin x is 1 by sin x. And then what is the third one? Sin x differentiation cos x. 1, 2 and 3. So cos differentiation is minus sine and log differentiation is 1 by value of that, and sine differentiation is cos. Now cos x by sin x is cot x, minus sine was here, that is there in this, into sine of log sin x. Friends, you need to be very, very clear when you are doing these things. See, these are all the questions that you get in CET, and these questions, without any mistakes, you must crack it. It's very, very essential that you put a lot of practice in solving this. Once the concepts are clear, I think nobody can stop you in getting the right answers. Hope the concepts are clear and the problems are what I'm taking is also clearly known to you. One more. Log of tan of root x. Log of tan of root x. I have here 1, I have 2, I have 3. There are 3 functionalities that need to be differentiated. So the number 1, log, it is 1 by, log x is 1 by x. So 1 by tan of root x. Tan of root x. Next, second differentiation, tan root x differentiation. Tan x differentiation is secant square x. Tan x differentiation is secant square x. So secant square root x. Why root x? Because tan of root x it is. Secant square root x. And third, differentiation of root x. Differentiation of root x is 1 by 2 root x. So what are the 3 things? 1, 2 and and 3. 1 by 2 tan root x into secant square root x into 1 by 2 root x. So do I have to simplify this further? If this is your option, because you will have 4 choices, and in that if you see this as the answer, you don't have to proceed further. If it is further simplified, then only you need to do that. Is this clear to you? Y equals e power log x by x into y equals e power log x by x into log of e power 1 plus tan x. Find dy by dx. Y equals, friends, this is one thing that you all need to know about it. E power log x is log e power u, which is u. E power log x is, answer is x. So it will be x by x. Similarly, log of e power 1 plus tan x difference value is 1 plus tan x. These two cancels. 1 plus tan x differentiation. Differentiation of 1 is 0. Tan x differentiation is secant square x. Tan x differentiation is secant square x. Hope this concept is very clear to you, friends. E power log x is x. Please remember this. Any value to the power of e, base, if it is e, its power is any of the other value, that itself will be its value. See, e power log x is x. Similarly, e power 1 plus tan x is equal to 1 plus tan x. Got it? Then, now what is to be done here? X cancels. Log of this thing, e power 1 plus tan x. Log of e power 1 plus tan x is 1 plus tan x. So 1 plus tan x, in that the differentiation of 1 is 0. Differentiation of tan x is secant square x. Very, very important, friends. And they give you this as the option, and many a times you totally get confused. Sum is so big and answer is so simple. Can this be? And you will have in all this kind of cases none of these as one of the answers, and you get lost. Fine. Let me go into the next one. Very, very interesting. I would say very important sum. please make it a point. This kind of sums you practice a lot. You know this very well. Y is equal to secant inverse of, let me say this as theta. This whole value I'll take it as theta. And this is also theta only. So now look here. Y equals secant inverse theta plus cosecant inverse theta. Secant inverse theta plus cosecant inverse theta, or secant inverse x plus cosecant inverse x is nothing but pi by 2. Y is equal to pi by 2. Friends, this must strike to your mind. Two such cofunctions, one side it is secant, the other one is cosecant. Secant inverse x plus cosecant inverse x, if it is there, its value is pi by 2. If this strikes to you, friends, you get an answer for this, because first option you will have 0 in it. You will never look at it, because you don't analyze that this sum will get 0 in it. And that formula, if it doesn't strike at that particular moment, you are lost. So if you get y equals pi by 2, pi by 2 is a constant value. Differentiation of pi by 2 is 0, friends. Am I right? Differentiation of a constant is 0. Look. When you look at the sum, it looks so complex, it looks so big, it looks so heavy. But its simplification is so simple, only because we know the formula here. So until and unless the formulas are strongly put in our mind, we can't crack these problems. One more. Y equals x into tan x by 2. This is uv. V into u dash plus u into v dash. So v is tan x by 2 into u dash is differentiation of x, which is 1. Then u is x. Differentiation of tan is secant square x by 2. Friends, this is an punchline here. If you stop here, secant tan differentiation secant square and its value is x by 2. If you stop it, you are lost. Secant square x by 2 into 1 by 2, because x by 2 differentiation has to be done. And you can't forget it. Chain rule, tan of x by 2, I am differentiating this secant square x by 2. I differentiated tan. Now x, it is, if always x differentiation is 1, so we don't write anything, thinking that we never touch x at all. But here x is not a, it is x by 2, half angle. So 1 by 2 is the value that comes over there. Okay. Now further things are all mathematical operations. Tan x by 2, they have split it as sin x by 2 by cos x by 2 and plus half into x into secant square x by 2 is written as 1 by cos square x by 2. Now please see, a cos square x by 2 is taken as LCM. 2 also exists, so it is 2 into cos square x by 2. 2 into cos square x by 2 is the LCM value. Now in this what happens, you have only cos x by 2. So one more 2 into one more cos x by 2 need to be multiplied. So it became 2 into cos x by 2 plus on the second value it is only x because everything exists here. See here friends, it's a half angle formula. We knew sin theta to sin 2 theta is 2 sin theta cos theta, but it's half angle here. 2 into sin of theta by 2 into cos of theta by 2. So sin 2 theta becomes at its half angle sin theta sin x. Right? It is sin x plus x by 1 plus cos x. Sin x plus x by 1 plus cos x is the answer. Last two sums for the day, friends. I'll try to finish with this. Hope I'm not boring too much. But these are all very essential ones. If y equals log x by x, what is dy by dx? Friends, we have to understand this is u by v, quotient rule. And what is quotient rule? V into u dash minus u into v dash by v square. What is v? X into u dash is log x differentiation 1 by x. Minus is here. Then u is log x, differentiation of x is 1 divided by x square. X cancels. It is 1 minus log x by x square. But they have said for 1 minus log x by x square, for this they have told you to substitute for the value of x as e. When you put x is equal to e, it is 1 minus log e by e square. So log e to base e is equal to 1. So 1 minus 1 is 0. 0 by e square is 0. Hope the concepts are very clear to you. Last sum for the day. Y is equal to log of cos of root x. We have already done this kind of chain rule. So please understand there are three functions, 1, 2 and 3. Log differentiation is 1 by cos root x, and cos differentiation minus sin root x, and root x differentiation 1 by 2 root x. So put it together, minus tan root x by 2 root x. Where is the answer? Minus tan root x by 2 root x. The third one is the right answer. If the concepts are very well known to us, I think we reach to the right decisions. That's it for the day, friends. I hope you have enjoyed differentiation here. There is a lot more to practice. This is just a beginning. There is a lot more to know. I'll come back to you with one more class with some more examples. This is Manjunath signing off. If you have liked these classes on the YouTube, press the like button and subscribe the channel. If you have already done it, thank you very much. We'll meet in the next class. Manjunath signing off. Have a nice day.